This is podcast 3.2 for chemistry, and we're going to talk about naming ionic compounds, and we're going to do binary ionic compounds. So rules for naming ionic compounds, really simple. The first rule is you just name the metal, and you don't change the name of that metal. And then the second one is you name the non-metal, and you change it to an "ide" ending. So when you name the metal, you don't change it. So don't change. But when you name the non-metal, you change it to this "ide" ending. So here's some examples for us to do. The metal always comes first, the non-metal always comes second. The metal here, we look it up, Na is sodium. So sodium. And then Cl is chlorine, but we change it to chloride. We want that "ide" ending on all these non-metals. So sodium chloride. Mg is magnesium. And then O is oxygen, but we change it to that "ide" ending, so it would be oxide. K is potassium. And then Br is bromine, but we do bromide. And then this last one here, Ca is calcium. And then Br again is bromide. Notice that even when there are subscripts, and the subscripts are these little numbers down below, it doesn't change the name of these compounds. So the number of them does not affect how you name them. We don't use prefixes with ionic compounds. It's really simple, just sodium chloride, magnesium oxide. Just remember to change that second element's ending to "ide." And then when we're writing ionic compounds, it gets a little more difficult because we have to look at charges. So all compounds are neutral. That means that our charges are going to have to cancel each other. And if we remember to what we've been talking, these are the charges that we've been doing. And then there's no charge there. So we're going to use these charges. Transition metals have varying charges, and we're going to ignore them for now. We'll come back to them in just a second. We're going to stick with these guys who have consistent charges. So we use those like this. Our first example here is lithium bromide. Lithium is in group 1A, so it has a +1 charge. Bromine, because that would be bromide, has a -1 charge. A +1 and a -1 equals 0. They cancel each other out. So that means I just need one of each. It would just be LiBr. Sodium is a +1. This is sulfur, and that has a -2 charge. I'm going to need 2 of the sodiums to balance out my 1 sulfur. So this is going to be Na2S, because I'd have to multiply this by 2 in order to make it cancel that one out. Aluminum is a +3. This is chlorine, and that's a -1. This time I need more of the negative charge, and I'm going to have to multiply that by 3 in order to balance out the aluminum. So this is going to be Al, one of them, and then chlorine, and I need 3. Calcium is a +2, oxygen is a -2, so again I just need one of each. It's just CaO, because a +2 and a -2 give you a 0. They cancel each other out. Aluminum is a +3. Oxygen is a -2. Now, I can't multiply anything by 2 to get to 3, and what you look for is what's the number that they both go into, and that would be 6. So +2, if I multiply that by, or +3, if I multiply that by 2, will give me a +6. And I have to multiply this by 3 in order to get a -6. So that means for the aluminums, I need 2, and the oxygens, I need 3, because I tried to balance them out with a 6 charge. Potassium is a +1. This is nitrogen, and that's a -3. So I need to multiply this by 3 in order to balance this one out. So this would be K3N. So when you're doing these, make sure your charges are going to cancel. They're going to add up to 0 is what you're looking for. And we'll do a lot more with these in class in terms of practice. Okay, and that's the end. So not a whole lot in this podcast, but we're going to do a lot of practice in class. Make sure that you're comfortable picking out the charges of those metals and nonmetals so that we can make these compounds.